Hello everyone. In this video, I'm just gonna run through some really basic plots in R that's useful when you're doing exploratory data analysis. So let's get started. Um, First, I'm importing the dplyr and ggplot libraries. They've already been loaded, so I'm just importing them now. Okay, so then next I'm going to import the cancer dataset, which is the same test I used in one of the other videos. Um, I'll put the link. I'll find the dataset and I'll put the link in the description. I just have it on my computer. But anyways, all right. So we import the dataset, right? And then if you just to get an idea of like these basic functions, you should check out my other video that shows, or like any other video on YouTube that shows you the basic functionality of I'm not gonna go into that here, but just for reference. Okay, so first let's plot a scatter plot of just a simple scatter plot of two variables. Just to okay, let's just take a look at the cancer dataset real quick. So this is what it looks like. It's got one categorical variable, which is the diagnosis, whether it's malignant or benign. There's a case ID number, which is not, it's just a patient case ID number. So the numerical value doesn't mean anything. And there are a bunch of continuous predictor variables, right? These are all measurements, and x is empty. Okay, so we'll be using those variables to run a lot of the plots on this video. So first, let's do a scatter plot, and I'm using the piping operation. Like you see this piping over here, like I did in other videos. Okay, so let's run this line of code, and we get a very basic scatter plot. You can see we're using the ggplot package, right? Which we import using the ggplot2, and we set this AES argument. So this is short for aesthetics. So you tell R what you want on the x-axis and what you want on the y-axis out of this data set that you're piping in to the function, right? So you're piping in the cancer data set into this ggplot function, and then you're telling it, hey, okay, I want within this AES argument, you're saying, hey, I want x to be the radius, y to be the concavity mean, the two variables, and then I want to use a geom point function. So actually, so there are a bunch of different versions and a bunch of different plots, and to add all of them, use this syntax. And you say if you hit tab, you can see all the different kinds of geom objects you can plot on there. Okay, so let's put it back. All right, so it's pretty straightforward. Then let's plot. So let's say you want. So this is a two-dimensional plot, right? Let's say you want to plot three dimensions of information on one two-dimensional plot. How would you do that? Well, it's the same thing. You make a scatter plot, but instead to display the third variable, we use this color. We use point coloring. So we color the points on the graph depending on what we want, what the value is. So let's hit enter on this. Sorry. You can see what I'm doing here is it's the same scatter plot as you plotted up here in this line, but now we're coloring the points depending on whether it was diagnosed as malignant or benign. And you can see that we immediately you can see that cancers that sorry like tumors with a low radius mean and low concavity mean are mostly benign, and then as you get high on both axes, you get more cases of malignant, more cases diagnosed as malignant. So this is a useful way to see plot three variables in a two-dimensional space. Okay, next, um, let's say you want to plot. Okay, first, okay, so here what I've done is I've added another categorical variable. I've just added an arbitrary categorical variable, right? So here what I've done is I've added another column to this cancer data set. So right now it's not on here. So what we'll be adding is this a column called grad mean, which as you can see is not on this data frame right now, but we will add it now. I'm just adding it just to have another categorical variable, and I'm doing something very arbitrary. So I'm just saying if any. So what I'm saying is send the cancer data set into this mutate function, which we discussed in a different video, which will update the this data frame. So use this data frame, then use the mutate function to add this grad mean column to this data set, and I want it to be a factor, right? So all this is saying is I want a factor of zero, yeah, and then I'm using the if else statement to say if that row, so if an observation has a radius mean value greater than or equal to the mean of the entire data set it to 1. If not, set it to 0. So it's just an arbitrary thing. So if any row, if any of the, if this value is, if 18.2 is greater than the mean value of all of these, set gr mean of this, set that column value of this row to 1, else set it to 0. Okay. So once you've done that, oops, once you've done that, you can see that it's now a new column in the dataset called grad mean. Okay. So once we have that, now I'm going to do that's just for later, so we can have at least two categorical variables to play around with. Okay. So next, I'm going to do create a stacked bar graph which shows different proportions. So once again, you should remember use as factor on the categorical. So if I hadn't already defined grad mean as a factor, I would have to use as factor here. But to make sure that all your categorical variables are, like you tell R that these are actually factors and they're not numerical like values. Right? Okay, so we run this. So what you find is here. So we get the raw counts on the y-axis for each case of diagnosis. So raw counts for benign and raw counts for malignant, and we also get the proportion of each. So this shows what proportion of benign tumors were below the radius mean of that and what was above. So remember that we made this categorical variable earlier. I made that just to show you this functionality. Okay. So we're basically making a bar chart. We're showing the counts. We're showing two classes, and then we're further dividing each class into either another variable. So this could be any other variable you want, as long as it's categorical, right? Okay. So the next one we're gonna do is we're gonna make a side-by-side bar graph of different groups. So instead of putting it all in one plot, we're making two different groups. So here I've also shown the functionality of rotating the axis labels. So I've just used this line of code to rotate the label 90 degrees. It doesn't make a difference here because it's just one letter, but if you have a big label, you might want to do that. Anyway, so here what we're showing is there's a count, right? We have two different groups, benign and malignant, and then instead of like earlier we had this, right? Now we have the same information, but it's side by side. So benign, how many are 0, and then how many are 1, and then for malignant, how many are 0 and how many are 1. Right? All right. Next. So now instead of using the proportions, like instead of using the raw counts as you've done here, this is the raw number of observations. We can create a graph that shows just the proportions. So now this is out of 1, which means it tells you what percentage of the observations are each of these different things. So this says in the malignant group, how many, what are the proportions of 0 to 1, and in the sorry, the benign group, and in the malignant group, what are the proportions of 0 and 1. Pretty straightforward. And you do that with this. And I've also shown the functionality for uh, adding a title and then centering it. Yeah, okay. Next, we create a faceted bar graph. Here, what we're doing is now I am creating, like I'm separating this out into the grad mean variable, right? So this is saying, so now there are two groups here. This one shows where gr red mean was zero. Of the points where gr red zero, sorry, excuse me, gr red mean was zero. What are the benign and malignant distributions? And here, of the group that where gr red mean was one, what are the distributions? So it's kind of the same information, but different ways of looking at it, right? From this, and this. Okay. Now I'm just going to show you how to do the raw counts of any one variable. So I'm just showing you this, how many are benign, how many are malignant in the diagnosis variable, and you can set it to whatever color you want. And just set it navy here. Okay, and next we're gonna create a dot plot. So dot plot is like a histogram, but it should, instead of okay. So what's happening here is so radius mean is a continuous variable, right? If you look at this right here, it's a continuous variable. So what's happening here is we're dividing it into bins, and I'm saying zero point 0.6. So each bin is width is a zero point 0.6 bin width. So we are discretizing a continuous variable, and then we are putting each observation. What if an observation falls in that bin? You're putting it as a dot. So each dot is an observation, right? And then they are stacked on top of each other. So it's basically frequency, showing you, okay, so how many dots here corresponds to the frequency of that value in this data set, right? Okay. Now we can create next we can create a faceted histogram. So if you look at this, it defaults to a 30 bin size of 30. You can specify that in here. So what's happening here is we have the radius mean on the x-axis, and we have the count on the y-axis, and you've gotten two plots here, uh, and each plot is one level of the diagnosis variable. So either it's benign or malignant, and then we get the distribution of the observations in the benign category and then in the malignant category, and it gives us a radius mean. So we see that for the benign group, uh, the radius mean, we have looks like, we've got a lot of observations somewhere in the middle of 12.5-ish range, and then not so much outside. And then for the malignant case, we can see that there's a much higher variance. Right? Okay. Um, so let's look at and by the way, this is done by using this passage wrap uh, argument, right? And then you do you and you and you and you spe- and you specify with the tilde what what variable you want to facet on. And then if you notice, like, all of these objects, you add all these layers, you add on to the plot, right? You add the plot, then you add the geom bars, you add the passage wrap. So each layer is added on with a plus sign after this ggplot function. Okay, let's create a box plot. Okay, so here what we're doing is, again, if you notice here in this line of code, I've had to specify as factor. Well, what I could do is I could just change the data frame and make this whole variable as factor if I wanted to as well. But in this case, since it's not a factor, I have to explicitly tell R that hey, this variable is a factor, and I want to use it as such. And then once you've specified that, you can use a box plot. And here I'm saying, okay, put on the x-axis, put the different groups, so benign and malignant. And then on the y-axis, show me the radius mean. So this, right? And then you get a nice box plot here. Box plot here. All right. Um, I'm not going into detail about what this data actually means. Like I'm just showing you how to create them in R. So there are plenty of great videos on YouTube that'll explain what how to read one of these. Anyway, um, okay. So next, here I want to show you just like the functionality of using a pipeline where basically I'm piping the cancer data set into this filter function, right? And then I'm pumping the output of that into the ggplot function. So it goes cancer data go into this, then we do some operations on the data, and then that goes into the ggplot function. And I'm gonna use that to create a density plot. But I'll show you actually sorry, yeah. Let me show you the density plot up here first. Okay, so this is a density plot. It's a lot like a histogram except it's smoothed out, right? And here you can set the alpha argument and change the opacity of these plots. So if I said there's no color, right? They're perfectly opaque and you can't really see anything. But if I hit like 0.4, you see the overlap, right? So what I'm doing is creating one density plot and then I'm layering on another one on top. I'm doing that by saying, hey, on the x-axis I want the compactness and I want you to fill with the different levels of diagnosis. So to do that creates two plots. I mean one plot but two graphs. Okay. And here I'm going to create another density plot, but I'm showing you the piping functionality. Same thing. Right? Okay. And then lastly, or not lastly, but let's say you want to do a grid of histograms based on two different levels. So let's say you have two categorical variables, and you want a grid of histograms showing how they're distributed, and this is how you do that, right? So you're saying, okay, I want to use the cancer data set, and then I want the x-axis to show the perimeter mean, and or whatever continuous variable you want to use. Then here I've specified the bin width for the histogram, and then I've said, okay, I want a facet grid and I want to use the variables diagnosis, which is a categorical variable, and grad mean, which is a categorical variable. I'm saying label both, meaning these two labels for each variable. So this shows. So you can see now. So you can see. Okay, for cases that are diagnosed as malignant, is will be on this row, and then you can say, okay, which cases had the grad mean of 0, this will be hit, and then you can see how they sort of follow different distributions, right, depending on where they fall. Again, this depends on how many data points you have for each case and etc. But this is just a demonstration of how this would work. Okay. So next, I'm gonna show you a box plot where I have cut a continuous variable into several different breaks. So recall that radius mean is a continuous variable, right? But here what I've done is I've said, okay, I want you to I want the x-axis to be the radius mean, but want you to cut it up into 5 bins essentially, right? And I want to make 5 breaks, so 1, 2, 3, 4, 5. And I want on the y-axis to be the concavity mean, which is another continuous variable. So I've basically discretized this x variable, and I've said, show me the box plot for each bin, and then compare it to the, in comparison to the concavity, and this is what that would look like. All right. And next is how I'm going to show you how to do a log transform, right? Okay, so first, I guess let me just plot this without the Lagrange transform. Okay. So if I just plotted radius mean with area worst variable, you can see this is sort of it's got a nice, got a bit of a, it's got a nice curve here. But like this is what it would look like. Now, if I did a log transform of both of these variables, you get a nice straight line, right? I've just transformed these scales into a logarithmic scale. Cool. All right. And then finally, last but not least, I want to show you a case where, let's say, for example, okay, so I'm going to show you something. But first, let me just comment this out. I'll comment it out. I'm just going to take this argument. Okay, so if I plot that, okay, now see what I've done here just for demonstration purposes is I've converted the radius mean variable into an integer value. So which means there will be some cases, like individual rows in this data set which will have the same value, right? Because they're integers, so they're discrete numbers. So some values in this data set will share the same value. So if you plot them out in a scatter plot, a lot of those points will overlap, right? They'll be on top of each other because they share the same value, right? Um, okay, but but it's kind of hard to see. So what we can do is we can add these two arguments. We can say, okay, I want to let's just take the jitter thing now. I'll show you the alpha thing first. Okay. So if I add opacity to the points, I can see that okay, so where it's darker, that means there's overlap, right? Because I'm making each point light. If it's really light, that means it's just on its own. But if it's dark, that means there's a lot of overlap here, right? And furthermore, then if I want to separate the points out even further, I can say position equals jitter, and that adds a little bit of noise, so it separates out. Now you can see kind of you add a bit of noise and separate out, and you can see where there's a lot of clustering, a lot of points seem to be in this area, and then it's fewer points in this area because you can see it gets darker over here, right? All right, that's it. Just some basic plots. I hope this is useful. Yeah, thank you. Thanks for watching.